So this lesson is about density. So there's a couple different things we need to talk about when we talk about density. We need to know the mass and volume of an object in order to calculate the density. So the mass is going to be the amount of matter that an object contains. So how many molecules are in that particular object? So matter can come in three different phases. We should know these are, there is a solid, there's liquid, and there's gas. There is a fourth state called plasma, but we're not going to be concerned with that one at this particular point. So we talked earlier about scientific method, and we need to use instruments. So we want accurate measurements. So the instrument that we use is a triple beam balance, or in earth science, what we're probably going to use most of the time is a digital scale. We have different units that we can use in the metric system. One are grams. The standard unit is the kilogram. And the last one, if we're talking about a small substance, we could have the milligrams. And that abbreviation is lowercase m, lowercase g. Sorry for that interruption. That was Mrs. Gerber at the door. So, we talked about the three states of matter, solid, liquid, and gas. And this graphic from NASA, from the Glenn Research Center, shows us a little bit more about those three states of matter. One, a solid has a definite shape. So if we think about a cube, or even if we think about an ice cube in that particular case, and we know that it has a definite shape and it has a definite volume that we can measure. Once it melts and becomes a liquid, or has its water, it now takes the shape of that particular container that it's in. In this particular case, it's a rectangle or a square. If it was a shape of a glass, it would take that particular shape. It also still has a fixed volume. We can measure that volume by putting the liquid in a graduated cylinder. And then if we boil or we vaporize the water, it becomes a gas. And a gas takes the shape of its container and then the volume of the container, because all the particles are going to be moving around in that particular container. So one other thing that we need to talk about are some terms that apply as we change from one state to another. So most of them we probably already know. We should know that as we go from a solid to a liquid, it's called melting. And then if you go from a liquid to a gas, it's called vaporize. Then if we go in the reverse order, if we go from a gas to a liquid, we're condensing. The condensation that you see on your car in the morning, especially at this time of year. Then as we go from a liquid, water, back to a solid, it's solidifying. I think we're all familiar, or should be familiar with those terms. So there's two other terms that we need to know, and these will come up later on in the year as we discuss weather. One is called sublime, or it could also be called to sublimate. And that is when we go from a solid directly into a gas. That happens with very few things. One, for instance, is a mothball. You put a mothball in a closet, it doesn't melt and become a liquid, it just goes into being a gas. If we go in the opposite direction, we're talking about deposition. So in that particular case, deposition is going the opposite way from sublimate. It's going from a gas, and it's going to become a solid. So two terms that you should be familiar with as we go through. So as we were just saying, we talked about volume. We know the mass of an object. We now need to know the volume of an object. And that is the space occupied by matter. How much space is taken up by that particular object. So there's two different instruments that we can use. One, we can use a ruler. I think we all know what that is. And two, we can use a graduated cylinder. And there are two different units. They are the same thing. We can write it as cubic centimeters, or we can write them as milliliters. Note the abbreviation for milliliters. lowercase m, capital L. And this is centimeters cubed or cubic centimeters, cm3 to the third power. We shouldn't be saying cm3, we should be saying cubic centimeters. So for volume, if we have a box or a known substance that we can calculate that particular volume, so in this particular case, our volume in this one is going to equal our length times our width times the height. Length, width, and height. We multiply those all together and we get our volume. So what we also need to know is that our units in this case are going to be cm times cm times cm once again. And when we do that, that's how we get centimeters cubed or cubic centimeters. So the other way for irregular substances, we need to do water displacement. Please watch the video that's on the YouTube channel or on your flash drive that refers to water displacement for a more thorough overview of this. But basically we have a graduated cylinder, we put a known amount of liquid in it, bottom of the meniscus, tip the cylinder gently on its side to allow the water to move so we can easily slide the object in, and that way we don't break or crack the bottom of the cylinder. The water level will go up, and then we subtract the difference between the two. The video on YouTube will do a better job of explaining that. So how do we calculate density, or what is density? Well, one, the scientific definition is mass per unit volume, or another way of saying that is how much matter is there in a given amount of space. And uniformly, that does not change. If a substance is not heated or cooled and nothing happens, it stays the same for that particular substance. So we have a formula, density equals mass over volume. So an easy way to try to remember that is using this cool little triangle. If we plug the numbers in, or the letters, I'm sorry. So down here, we would have D for density, up on top, M for mass, and down here, V for volume. So if we want to calculate the volume of an object, instead of doing some math to figure that out, we can write volume, and then what's left? We have M over D, so we write that down. M over D. So our volume is going to be mass divided by density. Let's say that we want to figure out the mass of an object. So what do? We take our mass, and what's left? Well, we have density and volume on the same line. So we write these down on the same line. So we would take, to find our mass, we take our density, and we multiply that by the volume. So if you can put these in the triangle, and that will work for any formula that has just 3 variables in it, we can calculate the density. So a quick little example here for our density. Let's say in our particular object, the density, our mass is 4 grams, or again, we need to have our units, and our volume is 2 cubic centimeters. Pretty easy math for this one. 4 divided by 2 is 2, and our units come out to be grams per cubic centimeter. So, what happens if we cut that object in half? Things change. If we cut the object in half, and let's write that down, cut in half. So now we cut that object in half. Well, if we cut it in half, we have half the mass. So now we have 2 grams. And if we cut the object in half, it takes up half the amount of space. So instead of being 2, it is now 1 cubic centimeter. So we go to calculate the density, and we have 2 grams per cubic centimeter. What have we just realized about the density? Well, if we look, we should realize 2 is the same as 2. So what are they? They are equal. I have a little note down here to myself. Make sure also you go and watch the 7-layer density on the YouTube channel. So, in conclusion, what does that tell us? No matter how we cut an object, it's always going to have the same density. And of course, we're assuming that the temperature has not changed in that particular object also. But with saying that, what do you think would happen if we change the temperature of an object, whether we heated that object or cooled that object? So what I want you to do in this particular spot, okay, write down a quick prediction. Nice, the pen changed color. So write down a prediction, and when we come in class and we go over these notes, we'll talk about our prediction and we'll look at a little bit of math that goes along with this. Hopefully you learned a little bit more about density, and please go and watch those 2 other videos off the YouTube channel, one on water displacement and one on the 7-layer density.